other listeners too in this chat. Have to log in. I don't know why, but it is asking me about a login. Okay, so good morning into the chat too. Okay, I hope you hear me, everybody. And today we do the last lecture. I think the 8th January. Yes, it was last week. And this week you get the recordings too afterwards. So what do we want today? What did we do in our lecture until now? So just to conclude everything we have been done in this semester, you already got a brief overview about the Android operating system and Android programming, as well as Kotlin programming language. That's what we did this semester. You have fundamental ground knowledge about creating Android applications, creating activities using the intent system, and in our last week we were starting to get some more information about adapter views, and this is a point where we go on today. So you were asking me last week how to deal with databases, and we were talking about accessing the file system, accessing shared preferences, and today we will talk about accessing databases, using databases in adapter views. Especially the cursor adapter is one thing we will examine today in this case. And let's build a small application again at the end of the semester. I was thinking about what to do, and my idea is we create a birthday application where you can save the birth dates of your friends, of your family maybe, so that you don't forget the birth dates. Okay, this is not a function which is really new, because those functions are in calendars implemented already. But if you use your calendar on your smartphone, you normally have a Google Calendar, and if you tell any data into your Google Calendar or in your contacts list on your phone, lots of applications can access your contacts. Lots of applications can access your calendar and can grab this information. So if you put this personal information, what is your birth date, or what are the birth dates of your friends, into your phone and put it into your contacts list or put it into your calendar program, then you give those data away to other programs, to other providers, which can grab this information and build a whole picture of your world and your surroundings. So if you have a friend which is afraid to use a smartphone and to put in data because he's afraid that the data is going away to other companies, if you know some personal data about him and you put it in your phone, it's the same as he would put it in his. So that's why maybe we should think about security as well. And one point is save personal information, save personal data, and control it. So control who can access it and who hasn't granted access to personal data. And one thing is the birth date. The birth date is really personal, so everybody's happy if you call him when he's on his birthday. In some countries it's the name day, so there's maybe in Catholic countries they like the name day, and this is something similar to this birthday, but here in my country we like to have birthdays and birthday parties and so on. And if you know when the birthday is, you can call, and then you get I want an invitation to the birthday party, and you can meet lots of people, and this is really nice. So birthdays are a really good thing to come to the people, yeah, and get entrance to them, and that's why it's personal. And we should save this. And I don't want to talk so much, so let's start our last lecture. Normally I would like to get today your exams, but we talked about last week that you like to have 1 week more to conclude, to finish your exam, and today we do some important things, or we go over some important things which are part of your exam. So I understand that you want to have some more time. You can get it, but next week it's definitely the end. I will not be here next week, so you know that. You have to email me if you are ready with your exam, and maybe we can do it over Moodle in our next lecture today. Before we leave, maybe I create some Google some Moodle exercise, and you can upload your stuff into Moodle. Maybe this is a good way too. Okay, so let us start. So we want to go on and do database access with Kotlin and Android, and we want to do some cursor adapter now. And as I already mentioned, we would like to create a application which is storing birthday information of people you know, and if you want later you can write a reminder and some things. But we start with a small base application using a database. Okay, so it's running, and what we need is our IntelliJ. Because it's very easy to use it. Yes, you have question, please.
I really I really need this application. It's really useful for me.
Mm-hmm.
Because normally the Google Calendar, in that way that I want to know the friend's birthday, it doesn't work normally for me, at least. And I really like to send congratulation messages
Mm-hmm.
when my friends' birthdays.
Yeah,
So
yeah.
I really like. I think this is a useful application, at least for me.
Ja, ich denke auch.
Oh, well, this is fine. Yes, it's. I think it too. It's really nice, and you can adapt and make things, more things, and I hope it's fun for you. So, very nice. Thank you. Okay, we start this time with a blank program, blank project, and go on from scratch. So start with nothing else than just a name, my birthday application. I call it my birthday application, and nothing else, just finish this one here, and let's see where it is here. So it's empty, and let's try to figure out all the steps once again, what to do to build up this application. The first step is, it is somehow somewhere deep in my project wizards templates, there is this Gradle version. Once upon a time I will figure it out where to change it, but at the moment it's this file here. It is somewhere copy and pasted into my project directory, so somehow I should change the template for this to get rid of this exchange every time. So, but if I sync afterwards, everything is fine. So the first step to think about is, do I have the right build tools version to build my project? And at the moment Android uses Gradle, so do we have the right Gradle version? It's the first thing to mention before we go more in deep in other problems. So there could be other problems, but we are glad that we don't have other problems than changing the main number, the main version number here of the Gradle distribution. So it's okay, everything works fine. We have our application build it, so we can go deep into source. We get this here colored, and we go in, we have a package, it's complete, and we can start with a new Kotlin class file. This Kotlin class file is my birthday act activity, and it's a simple class. We say, okay, it should be a activity, and that's the case if it is inheriting this class activity and doing some overrides. Just override this function on create, and then if we have this, we should set up a layout file. So we should set a content view, and the layout file should be some R layout birthday layout, but we don't have this layout at the moment, so let's create a new layout resource in the next step. So the first step, create my birthday activities, my first activity, and to see some things on our view, we could create view elements in code as well, but it's much more easy and it's recommended to do it in a resource file. So let's create a XML resource file in a folder called layout under this resources folder here. If I open it up in our project template, if it is empty, there is no file, no folder called layout, so we need to create a new folder under this resources directory. But it's simple. I just right click and say create me a new directory, and I can call it layout. So if I do it, I immediately get such a layout folder here, and we know, since we were talking about resources, the layout resource folder is a recognized folder where the Android tools go over and search after XML files and give those XML files a resource ID, where we have to create now a file called birthday. And if this file is called birthday XML, we can access it later from our resources with r.layout.birthday. So okay, let's create a new XML file, or just a new file here, and should be birthday XML. So now we have a file birthday XML, but we could go back one step, because this this dialog here has a point called layout resource file. Maybe it's much more interesting for us to create a layout resource file. So let's see. If we create this XML file, everything is fine. We could go on writing this XML file, but we can say create me a layout resource file, and then I can choose a root element, and you see my popular linear layout is already filled in here, and I go into and say, okay, it's birthday, it's called birthday, the XML will be appended automatically, and now I got the birthday XML. It's open, and it has this introduction here. So it is the XML annotation, the processing instruction, and then we have our root element. The linear layout is completely safe, and inside this layout I want to say, okay, what is part of my birthday activity? What do I want to see if I start my birthday activity? Maybe someone wants to see a secure PIN. If you have to give in your PIN so that nobody is able to see all the birthdays, maybe, but in our case we just want to open it, and what I want to see is a list, a sorted list maybe of all my friends and their birth dates. Maybe I want to have it sorted after the birth date, or maybe I want to have it sorted after the names. So both queries could be interesting for us. So one thing could be we want to see who is next, who's coming up next with the birth date. Maybe I want to have it rolling over, so in some kind of the next, who's the next is the most one which is up. So these are all things we could do with queries. You think of SQL tables, we can do queries, we can sort things in the database. Sorting and querying is a stuff that databases, SQL databases, can do very good. So let's try to do it with the database, and we can sort as we want. To list data, we already know we can use list views, and let's do here a list view. and I want to have the width of this list view matching the parent, and the height of this list view can be wrapping the content. So the difference between wrap content and match parent is that wrap content is similarly just be as wide or as high as the content inside this list view needs to have this list view be wide or high to view everything which is inside. So to view all the content, I want to have this list view as big as the content is. And if I have a match parent, I say, okay, let this list view be as big as the parent is. Normally the parent, if the parent is the root element, it is as big or as wide as your screen is. That's why this is here some inheritance from the screen sizes, and this is here coming from inside to outside, and this is coming from outside to inside. Okay, so this list view should get an ID where we can have access to it. So let's give it an ID. Well, it is maybe Android plus ID a list view. Okay. So we have created a activity, we have created a layout file and combined it with the activity. So if I go into my activity, I now should get everything fine. We can create it, but we forgot something. We forgot to say the Android system in my application package. There's now a new activity which is maybe startable. So this should be our starting point, and I have to tell it to the Android package system. In our manifest file, which gives information about the ingredients of our application package, I want to append some things here, and I open this tag so I can write inside my application several things. I want to define a activity. The name is already pre-selected. It's birthday activity. This point is not necessary, but I can write the complete path here. My birthday application. I can write the complete path. I can leave it completely blank, or I can do a dot which says take the complete path and append this to the package name. So all three kinds are possible. If you have several packages or you have a very huge application where several developers are working on, maybe it's a famous game or something which is really complex often, then you should have packages and you should have activities in different packages defined, and so that's why there's the ability to give the package name to select a activity from different packages. But we have only one package, and the only one package here is the one we get appended automatically. So it's the C.Schaller my birthday application here. Okay. So we may not forget to give a intent filter. Intent filter is very important, because without a intent filter we aren't able to start up this activity. So we say this activity recognizes the action with the name Android main. So here we can select. That's really fine. In this IntelliJ, we can select directly the different Android actions that are possible to recognize, and we can say, okay, Android system, when you install my application, I have those activities, and they can react on those actions. So I can have several actions. I can have very much actions here, but at least I just want to have this main action, which is a startable activity. The activity can be run normally, and every intent filter needs a category. We know this, and we have two categories to decide from. The one is default. This is always the category we should choose. If we don't know which category we want to choose, we should always choose the default one. But today we know if I choose the launcher category, I get a launcher for my application on the desktop or in another activity, because everything in Android is a activity. And if I go into my Android operating system and I switch up to see all the applications installed, this is nothing else than to open up a activity which is coming from the system, and this activity is scanning over all your your applications and creating icons which you define here. So it is looking for all activities that have a intent filter with the action main and the category launcher, and then those can be started. And we can give this activity a image as well if we want, but maybe later. So okay, we have the manifest, we have the activity, and we have the layout. That's why that's now the point where we can do our first start of this program. I started for the first time, so my emulator was starting, and then this application should come up too. So it's compiling, still compiling, app building, merging some first steps, and now it is coming up. So here it is. We are ready to go on creating our program. Okay, we have a list view in our layout, and as we know, a list view is a adapter view. We need some data now, so we need some data to fill it into my birthday activity. And as we mentioned already, where does the data come from? The data is coming from a SQLite database. To access SQLite databases, we need at first a SQLite database helper object. This is a concept in Android which is very common to access databases. So we need a SQLite helper. The SQLite helper is a abstract class, and that's why we have to define our own abstract our own SQLite helper object, which is responsible for creating and accessing our SQLite database. Okay, so we need a new class here, and we say, okay, it's since the abstract base class is called SQLite database helper, we could say, okay, this is our birthday database helper, or just birthday helper. It's my birthday helper, and this birthday helper should be derived from SQLite Open Helper. SQLite Open Helper is the choice I want to make. I have some other possibilities here, but it's not so interesting for me. There's some other SQLite database classes too, but SQLite Open Helper is the one we want. This SQLite Open Helper has a distinct constructor. We just want to choose which constructor we desire to use, and I prefer, there are 1, 2, 3, 4 ones, since I don't know how to create those SQLite database parameters, but I know that I don't need a cursor factory. It is with a question mark, it can be null, so everything here can be null. We could create it with null, but we should create it with a context, we should create it with a name, and we can leave out the cursor factory, but this is important too. It is a version number. Every constructor has this integer number, and it seems to be very, very important to have this integer number, the version number. So what you've seen, what was automatically created is quite much. We have a context, we have a name, we have this factory here, and we have this version. We can a little bit condense this information. So The context is coming from our activity. We know the activity is itself a reference to the context, and since we want to access the database from our activity, from our list view, from our cursor adapter later, we get this context information from the activity. Okay, so the context coming from outside, the name of the database. This is something we can define by ourselves. We could say, okay, the name of my database is simply birthday. Maybe this, birthday. Okay, so we have this parameter now fixed. The factory parameter can be null. We don't want to think about a factory, so we say take some default things. We want to give null here. It is okay to give null here, and we have a version number. This version number is not necessarily needed to know it from the activity, so the caller of this birthday helper should not think about version numbers. That's why I take it away and give it into a standard version, and the first version should be version 1.0 maybe, but it should be an integer number. That's why 1.0 should at least be number 10, or maybe you want to have number 100 to say 1.00, to have a major number 1 and then a double number for the minor numbering. Every change you do needs a new version number. This is very this is not such a nice solution, but it's okay. The Android system is dealing with this version numbers, but we as developers have to increment this number after every change of our database. So if you forget to change the version number, you get in really hard exception and error finding problems. So you must be aware of this version number all the time. It's not so nice. So it is an abstract class, the SQLite Open Helper. So since it is abstract, we should override some methods, and we can do it automatically. Just go with the cursor over this name, which is underwritten with a red line, and go implement members. We can choose to implement the abstract members. Both abstract members I want to implement, or I have to implement both. So just override both methods. It are only two ones, so we have a function on create, which is called when we first create the database version 100. So if I use SQLite Open Helper with version number 100, and we have no SQLite database with the name birthday, or we have a older version, then on create or on upgrade is called. If we have this version already in our Android system available, none of those methods is called. So those methods will only be called if we don't have a version in our system. Then on create is called, or if we have a older version in the system, and then on upgrade is called. So on upgrade will be called whenever an older version number of our database is available in the underlying Android system, or the installed activity. We could write in the installed application, which is clear. And the other method is called on create, is only called when no version of this database is available on the phone. Okay? These are the criteria when one of those methods is called. And I can control it with the version number. So if I increment the version number, I have a database, then I have a database with an older version, and I can recognize, okay, there is on the phone, there's version number 100, and now I come with a new version, it is maybe 300, so in between are 10 differences, and I have to define, and this on upgrade method can be really nasty, I have to define what to do if somebody's out there with a database of version 100, and I have to do 10 different steps to bring it up, to build this database up into the version number this application, which is now installed, is using. So it is you can imagine it is a very nasty stuff to do this. The easiest way to do: throw everything away and create it from new. So export everything maybe in some other kind of format, maybe CSV style. Export everything and import it from new, maybe. So to have some general solution, I would prefer create the database here and just create it again. So for us, we just want to recreate the database. So if we do a upgrade from a older to a newer version, we just say recreate the database. Throw everything away and recreate it. During development, it's really cool to do this. It is easy to recreate, throw data away and recreate. So now we just have a implementation of this on upgrade. And if we want to implement on create, we have to imagine how to create a database. So we need SQL. So to create a database in SQL, or to create a table, because the database is already there. We have the SQLite Open Helper, which already has access now to a database called birthday. This database is called birthday, and we get already a handle to the database. The SQLite database is one or more files in a folder called birthday, and we want to create a table with this object. This object is creating a file in our private file system. Somehow, nothing else is happening in the background. So we just go into our database object, and this is a nullable object. So I ask database object, if you are not null, I can use you, and I just want to simply exec a SQL query, because there are lots of methods here. There are query methods which make it much more easy for me to query the database from Kotlin, and we have a insert method, but we have no create method. So we use the exec SQL method to give a SQL string which is creating my database. So we should start to say, okay, I want to create a table inside my database, and this table is called maybe birthday. Now you see it's the second time I use the word birthday, so I could define it as a constant value. And since this word birthday as a database name is not needed in the user interface, so it's just a internal naming, it's the name of my database and it's the name of my table, I don't need to define it in the values file down here in my resources, in the strings. This is just for strings which are visible in the user interface, so it is not needed to use the strings file and the resources here. You could do, but it's not needed to do so, because it's some internal stuff. Now we can reference to our birthday value at this point, and we can reference to our birthday value in this point. Create table. Birthday is the first thing, and after this create table we have two such braces and want to define the columns. So this is the name of the table, and now we need some columns. Okay, so the first column should be a ID column, and this ID column should be named _ID, because later on the adapter view says I want to have this ID. We could name it as we want. We could name it ID as well and say, okay, ID is a integer and it's a auto increment primary key. Auto increment primary key. So you know SQL, the first column is a ID column. The second column could be the name of your friend. The name is maybe a variable character, variable sized character with maximum size of 100 in length, and it should not be null. You know those constraints from SQL databases, and at least I want to save the birth date, so I want to have the date, and the date could be a timestamp. So and this should not be null as well. So we can have constraints in SQL. It's a full-featured SQL database, so we can really use SQL. As you know from the standard, we have those variable character, we have data types, and all those data types will be text. So everything behind this SQLite database is text. So it's storing everything in a text file, in a text manner. So if you write int, and if you write int with a length, it is not recognized by SQLite. SQLite does everything in text. So we could write simply text here, we could write text here, we could write text everywhere, but we want to have the information provided from SQL, because the SQLite driver is able to recognize what we write down here. Okay, so let's try to say this is my ID column and it's called ID. We later on can map it, can rename it, because if we query a column, we can say, okay, this column should have another name. It is possible to do so too, but we have to be aware of this ID, because the adapter view accesses your database entries and want to build them into the list view to produce output for the user, and therefore it needs some identifier, which is a number, a integer number, to say, okay, this is number 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. And after this ID column, it will sort, or it will provide access your database entry, your data set. Good. So now we have a database. We can try to compile it once, but it should compile, I think, problemless. Okay, we have our first database, but we don't have data. To make it easy, we could write some insert into our table. The table is called birthday, and the next string is a so-called null column hack. We can give something here. If there is a null column, this string will be reproduced, but we can have a empty string here. So if the column value is null, the string should be empty, which is returned, but we don't have a null column here. We have everything not null. So now we need some values, the content values. I can call it content, and those content values is a object, and I can put some values into this content with the put methods. Just if I want to insert stuff, I need a content values object, and in this content values object I have pairs, so it's something like a map. It's a mapping of column names and values. So I map values to column names, and I can put this content object into my database object with this in this insert method, and this insert method is then creating some data set in my database tables, or in my database table birthday. Okay, I want to put a name. So now we see the next thing, the name and the date. I need it again. I have to access the column names, and to access the column names we will do some fine Kotlin stuff. We use a companion object, and this companion object just has a name, which is name, and just has a date, which is date. So these are my column names. Column names as Kotlin style companion. Now I can replace the value name and say, okay, it's name, and I can replace date and say, okay, it's date. Here, maybe we do the same with the ID. We can do the same with ID is ID. Can replace the ID here. Okay, now we have it really easy. We say put name and give it a value, maybe John Doe, and put his birth date. Maybe it's what is today? The 15th of January in 2021. So it's a really super young guy, just produced today, and inserted in our database. Or we make it from 2020, so he has his first birthday today, so we can congratulate John Doe for his first birthday. Good, so try to build it, but we are sure it will build, so everything's fine. We prepared a database, and this database has a version number 1.0, or in integer 100. We created a simple database table with 3 columns. One is just a auto increment number column for our primary key, and the others is a name date combination. Both may not be null, and since everything in SQLite is text, we have the possibility to write text everywhere. It's simple. Okay. The next step must be to go into our activity and to define this cursor adapter. How to bring now the list view on the one hand and the database on the other hand together. And this is the adapter view. We go into our birthday activity, and we need this import of Kotlin X. Import Kotlin X Android synthetic, and here we want to have main and birthday dot star. This is our import, and since we use this import, we can access our list view directly. So the list view should get an adapter, and this adapter should be a cursor adapter, but the cursor adapter is abstract. There is a cursor adapter class, but this class is abstract. So we have to give the context into this cursor adapter, and we have to give some more things into the cursor adapter, but it's an abstract class. So here we need again an own implementation of cursor adapter. And this makes sense because the database we create is our own database, and the Android system isn't able to find out what kind of database we have. It has no knowledge about the columns, it has no knowledge about the data fields and the values and the number of columns and so on. So we should always create our own cursor adapter, because it's not possible to create a standard cursor adapter. Okay, so go on. Like the birthday helper, we create a new Kotlin class file, and it is our birthday adapter. Birthday adapter. Okay, adapter. Yeah, fine. The birthday adapter will be a special cursor adapter. And we have to realize again the constructor. We can choose from 3 versions. We want to choose a good version. The first version is deprecated. I've already checked it out, because you see it is deprecated, but the second version and the third version of this constructor are able to or can be used. So I go on this cursor adapter class name, and I want to have the second version. The second version of this cursor adapter uses a context. The context we know already is coming from outside, it's coming from the activity. The cursor is coming from outside. We could create the cursor inside, but then we should write a primary constructor down here to create our own cursor inside the adapter. Is possible. And the third parameter is the order requery value boolean. We can make it default. We can make it default and say order requery is true. Cursor, we want to have it as a parameter, and context, we want to have it as a parameter. Then we implement the members, and there are again 2 new members to implement. This is a adapter view, and last week we talked about adapter views too. We have seen the adapter view is responsible for creating list entries, and we already talked about that the number of list entries on your display is it's not endless. So it's a fixed amount of elements which can be shown on your display. It is bound to your display size. So if you have a smaller display, you see only a handful of entries, and if you have a bigger display, you can see lots of more entries on one view on your display. And therefore we have the adapter, which is able to calculate how many entries can be displayed at once on your display, how many entries should be created, and it is able to check, do I have so many entries in my database or in my resource which I want to produce in my list view. So if I have only 1 entry, I think it's no problem to produce this entry and show it directly on the screen, but I need only 1 view for this. And that's why we have 2 methods here. We have one method called new view. This is called for every new view element which is presented on the display, called for every new view element which is presented or visible on the screen. And if we scroll in the list, so think we have more entries in the database as we can view once on the display, we can scroll in the list, and what's done then is not creating new views, because it's quite a expensive operation. We create some graphical output, images and so on. We can just rebind this view. This is for rebinding. If the user scrolls through the list and new data should be shown or displayed, then no new views are created, but they are newly bound. So this method should just change the data in a already existing view. The bind view method just changes data in an existing view object. So it is really fast if we use this bind view. If our display is already full of entries, full of new view entries, so I have more data in the database than items on my display, I just and if I scroll, I just rebind, just switch the text, and the items will go up and down. So you think it is scrolling, but it's just a trick. So it's for your eyes. It is just going up and down, and you think, oh, it's really scrolling, but behind the scenes, it's just changing the text, and this up and down graphical trick is suggesting that it is scrolling. Yeah. So both methods are needed. For the first time, until the screen is full at once, we have to or we get new views created, and there will be some views outside the list, above the display and underneath the display, so that you can have this effect of scrolling. You need 2-3 entries outside, and you need some time to switch this bind view and to be a very fluent animation. There we need some more views outside the display, which can be shown very fast, and then the system has time to interchange the data, rebuild and rebind this view, and it's really fast then. Okay, I think you know what I mean. Good. So far, we just log here once, log the birthday tag, and say, okay, a new view should be created. We have to deal with this job to create a new view by ourselves. And in the second part, a new view should be, or a new element should be bound to an existing view. A new or a next element, Okay, good. So far, and we have to return this view. So here is a return value. We have to return this view. We can just return null here once. Oh no, null is not okay. We give back a new view. at the moment. We have to return something, so we can give at least a view element. This is not correct. This is not the correct return value. We have to create a view which is a item, which is a visible item, but we can have a empty view object here as a mock return value. So we have this birthday adapter, and we want to create this adapter view now in our activity. So we go into the activity and we say, okay, I want to have here my birthday adapter. This birthday adapter needs as first parameter the context, the second parameter is the cursor, and the cursor is coming from our birthday open helper. The birthday helper now has a constructor with a context, and then we can give us a readable database. And this readable database can be queried with a query method. So let's talk about this query method. This query method has several parameters. You see them here. And the first parameter is always the table, or most time in those two versions it's not the table, but it's the first parameter is the table. Then we have a list of columns, which is a array of strings. So we start with our table. It's called birthday, like the database. The second parameter is a list of strings, a array of strings, and those are the column names we want to query. So we can just write now birthday helper name is our name column, and birthday helper date is our date column, and we can give as third column the identifier column, the ID column, birthday helper dot ID. The next parameter is then go into this one. We have table. The next parameter is then let's see what it is. I think a string, and the next parameter is then presented to insert replace away. Okay, let's see, string selection. This table is really long, so I go here. The selection, this is our select part of our query. So we have a query, and the query is always is select. So we don't have to write select, we just have to have our selection part. This is the where part. And then we have selection arguments here, which can be used in our selection. So we can leave everything blank, and the last attribute is a string 2, I think. So there are lots of strings needed. So we see here query, now we can see it. We have a string, the array out, string, array, string is null. Everything is null. We can define everything as a null because we have this nullable strings, so we can give every argument null. Since we aren't interested in the rest. Null. Okay, everything null. Once again, null. The selection argument may not be null. It should be an empty string. So now we see the arguments. Okay. Selection is a string. Okay. Selection arguments is a string 2. Then we have the group by, having, and order by, and limit. If we want limit, we can leave the limit. Group by isn't needed, having isn't needed, and selection arguments aren't needed too. So we can have this everything null here, except the selection. This should be a string, a empty string. If the string is empty, is a select star. So if we don't select anything here, everything is selected. And the ID column, and we see it afterwards as a exception down here. So I produce a exception, and I want to do that because you should see how it works behind the scenes, and that's why it's good to get this exception, because if you do it the first time, I'm sure you get the exception as well. So let's call this value cursor. What do we have here? We have created a object of our database helper. The database helper is a SQLite open helper so far. If there is no database in our Android application at the moment, it is first created. So the first time we call this, we construct this object, the onCreate is called. And then we just want to have a readable database access. We get a object with readable abilities, and we can query something from this object, and we want to query the table birthday. And the first argument after querying is after the table name. The first argument is the table name. The second argument is a list of column names. The third argument is our selection string. So it's the where part, and this is the projection part here. And then we have the selection arguments. So we can have those belong together. We can have some wildcards in here. So we have a numbered arguments stuff, and we can have the values here. So the selection arguments are the values, and we can just use these values in this string. This is somehow, maybe you know, printf is a formatting function to print data formatted, and the string of the format string of the printf has some wildcards to access parts of the following parameters, and those parameters will be then replaced inside this format string. And this is how it works with this selection and selection arguments. In this API here, we can write very small strings, and we can replace the selection arguments like numbered arguments. So \1 would be the second argument or the first argument. \0 would be the first argument in the selection arguments array. So this should be an array here, and we can address the elements like positional numbers, and we just write this one, and then we can say, okay, the name is like, and that. And then we should have here some search in our query. So this is how it works, but for our first test, we just say, okay, I want to have the select star, and the select star is grab everything. Okay, this is our cursor. Now we just want to see how it works. I create my program. Build was finished, and let's see if it is running. So we have the adapter. The adapter has access to the database, but it won't run because if I start it now, you will see hopefully a exception coming. So I started, and here is the exception. So let's see what the exception is. If we develop databases and you do it, you see some nice exception. It's fatal, and it is a runtime exception, and here in the middle, in the center of this exception, you see SQLite exception near auto increment, syntax error while compiling, create table birthday ID auto increment primary key, ID int auto increment primary key, name voucher not null, and here is a comma mistake. So we missed a comma between the last two columns. Okay, it's the first thing, the first indicator. So we have a error in our SQL string. This is here, no comma. Now we have this comma. Now this is a really working SQL string, and I can restart my application. But it crashes again. A moment. Stop the application. Start it again. So now it crashes again. Always on the same thing here. Birthday and auto increment. Let's see. Now the comma is there. And I'm not sure why compiling create table birthday ID int primary key auto increment is the last thing. I think I have to switch. Primary auto increment is the last part of this thing here. Let's see, this should go here. Once again, restart. What happened? Rebuild. Okay, restart and go into the logcat, and now we have it's only allowed on an integer primary key when compiling. Okay, integer, I should write it integer, so you see int is not integer. So now we get the database is created, and now we get another exception. This is the one I wanted to show you. We have a illegal argument exception called and column underscore ID does not exist. Available columns are name, date, and ID. Those columns we do have, and there is no column called underscore ID. So okay, the easiest way to deal with this is to change the name of this ID column, because we don't need this ID column actually. We can say, okay, I want to have it named underscore ID, and we just rebuild our program. But if we do this now, we get the same error again. We changed it. Now we have this column, but we get the same error again. What is the problem now? Still not such columns. What is the problem now? Can anybody tell me?
I'm thinking maybe probably we should delete the database that has been created and like refresh everything from like to start the creation of the database from afresh.
Correct. This is
So,
correct.
like we can do that, and I think it would work.
So to
So we
recreate,
can,
what did you want? Yeah, tell me, please.
What I might suggest is maybe we can go to the device file explorer, then delete the database, then create it to see again if it would work.
Okay, we could access the file system and the SQLite helper, but on the phone of somebody else, you can't go to the console and to the terminal access the file system. So we should use this API to delete the table, and then we say, okay, create table if exists is one thing we can append here. Create table if exists, If not exists, better. If it exists, we don't want to create it, and we drop it. We just drop this table. We exec a SQL query which says drop table if exists birthday. Then it goes away. Okay? So we drop it and we create it new. That's what we want. Now let's try again.
Proxy, can we use a database inspector for deleting the database?
On the I don't know if this emulator has some kind of SQLite inspector. No, it does not have, but we can use it on the command line. We can
On the bottom right of the integer ID or Android distributor, there is option which calls database inspector.
where is this option?
ID.
In the IDE.
Bottom right.
I think it's
Yeah.
it's a package also.
But we don't need it. But it's very interesting. But I haven't tried it out from the IDE. I just tried to use it from the command line. So we have a terminal here. We can access the Android debug bridge. I think is not recognized. Where is the so we should come to the debug bridge. We can do this. We can go to users Christian dot Android, I think, and we have there. No, not this. Where is the skk dot directory? Just let's see. There's somewhere this SDK installed, and it is under how is it called in Windows, in Microsoft. We can have here a special folder inside some local data or some application data .local somehow called. Yeah, so it is application data local app data. That's right. So we go in app data, and there we have local, and there we have somewhere our SDK. So in part of the SDK is the debug bridge, and from the debug bridge we can access the database with the SQLite inspection tools as well. So this is the way I know. So we have here Android. No, this was not correct. Android, and then we have SDK, and then we have this platform tools. There should be the debug bridge, and then we can access the terminal with ADB and shell. ADB shell, we have a shell, and on this shell we can use SQLite or SQLite 3, and this is a SQLite shell, and we just open up a database and can inspect this database. So directory, or we see here the file system. We could switch to data, and but the permission is somehow denied here because it's not rooted the system. We have the possibility to use SQLite 3 in a rooted connection. So let's try to root and use the shell. Now we have access to everything. In the emulator we can do this, and then we can change to our application file system where the database files are stored, and there we can use the SQLite. This is possible to do, but we don't need to do this because I think. So here you see DE shall serve my birthday application. And there we have some things inside, and maybe private data is in app private. But I don't want to search about, I want to show you this, how to deal it inside the IDE, and you mentioned to use a inspector, but we don't need this inspector because, as I said, we just have to change the version number to 101, just make a new version number here. And if we now recreate our or restart our program, since we have a new version number, we get called the onUpgrade. The onUpgrade creates the deep database anew. We delete the database and recreate a new one. So now our logcat, if we start it, should give us another error, I think. Still no such column. Moment. Rebuild. Stop it and start it again. So I exit this one. And if I go down, I get no such column ID when compiling select name date ID, but I selected the ID. Let's see, we should have the ID now because we made a new version. Always when we want to get this called, drop the table birthday and create the table new, or just drop it without this exist. Then we should come up with a running program. So let's see what we have. This program is running without errors, because that what we see here is the last error from before. If we clear this and restart, we should not see errors. So now our program is running again. Okay? So we should be always aware of the version number. We cleared the database, we dropped it, and we created it from new. And you say we have a inspector here. Let's please tell me, where do I find this inspector? Is it here in my
bottom right of the ID.
right click here? Bottom right?
Bottom
Database inspector. Oh, here,
Yeah.
database inspector. Oh, cool. We allow access.
It's connected to emulator.
Oh, fine. Okay, this is the database inspector here on the right side. And we can open a SQLite database from the device file explorer to see its contents. So we should have a device file explorer. This is here. Device file explorer is included. And then we can go into the device file. This is the same approach like I did with the command on the command line. I just have to find this device file where this file is inside. So we have it somewhere in our not in the storage, in the internal app data.
Data, I think it's data slash data.
Here, yes, data, and then app.
Data. The app?
The app, there we have
App.
been.
Yeah.
Yeah, my birthday application, and then we have a base APK. We have libraries, and there we have already been there. So these aren't SQLite files, though it's somewhere
I
else.
think it's data dot data. Yeah, the other data down.
This one here. Now
Yeah,
this is
so
one. Yeah,
yeah,
com. That's
Yeah,
right. Com
yeah, yeah.
Android, and there must be DE Shellsoft. That's right. Here, this one. And there we have databases, and then we have the birthday database. That's right. And we can just put it
yeah.
inside from the device file explorer. Open. And then we have to what to do. Birthday is not associated with a file type. The open matching files. Now open matching files and associated application. No, that's not what I want to do. So drag and drop is not working here, but this should be a database file, I think, to see its content here. Yeah, I want to open it, but it does not show me the content
So
here.
maybe, so maybe we can open it as an SQL file, maybe. Like not from here. From the where it showed the open with text and the I think double clicking it.
Double click. Okay, I get his.
Oh,
I
it's
get now
automatically
this
consumed.
automatically thing here. Look for another app on this PC. Yeah. So now it's a little bit damaged here. Okay, but we see we can try to. You have a file explorer here, and but drag and drop does not work in this database inspector. But it is opening. If you know where the file is, it is opening the file. So we could come with a command and go to the app data and app data local Android SDK again with the platform tools, and we can use the ADB shell if we root it, and then we can use we can switch there and inspect it with the SQLite 2. So it is data. Now we have it, and then it is DE my birthday application. So you have it again. There are databases, and here we can have SQLite 3 with the birthday application. And if we want to access it, we can say, okay, give me the scheme. This is the actual scheme here of the database, and then we can have a select star from birthday. So it's a SQL shell so far. It's really nice. We can manipulate everything here from this shell too. That's what I wanted to show you, but this is very interesting, but I think I did a mistake when opening. I should decide something else, or I should read a tutorial how to use this tool. Okay, I go back to our program. It's already running. Thank you for this hint. And we want to go into the adapter. Now we have a running database. We have a birthday adapter program. The birthday adapter is used now as the list view adapter, but the birthday adapter doesn't show anything. It shows only empty views. We see it here. Everything is empty. To create a new view, we have to do something that Android does if we load such layout resources. And loading layout resources from XML files is called inflating. So we have to inflate a layout, and it can come from our own resources, or it can come from the Android resources. To inflate layouts, we have a layout inflator class with static methods, and we can create a layout inflator for our context. And the context isn't this, it's now context, because I called this parameter here context. So that's how to get a object which is able to inflate graphical resources or inflate resources from XML. And here we can use this method inflate, and we can give this method a Android resource. We can inflate resources from different sources, our own resources, or the R layout classes. So we could have a own layout. That's what we do in the next lecture after our pause. And at the moment we just take the Android R layout and inflate a simple list item number 2. So the simple list item number 2 is a list item with 2 text views. This is good for us, and the second parameter should be a null pointer. We could give the parent, but the parent here is not correct. We should give 0 null pointer, and what we get back is a view, and this view we can deliver as result. Now we have a Android system resource, and this Android system resource should be delivered back. This is everything we want to do, so we can return directly here, and then we have created a new view. Just decided which resource, which view resource to use, which view resource to inflate if we create it new. So you see, inflating from XML is maybe a longer taking term, some milliseconds. That's why we shouldn't do it so often. And the next thing is to bind the view. This view binding will be called directly after creating the new view. Data binding will be done, and we take the view and go into this view with the find view by ID method. We just are looking after a text view, and this view ID is a Android resource ID called list item or text1. I think it's called text1. It's just simply text1. It is a text view. We want to write the name there, so I want to access this view object. It could be a null here, and yeah, this is the name, and then the second value should be the date. This could be text2, and we take the name from the cursor. The cursor then has the name, but this after the break, so we just make the break now. I give the name. It is John Doe, and the next name set text. I should use set text. Should be John Doe, and since it can be null, we have to use this one, and date set text birth date. Okay, if we do this and rebuild the application, it should now work, and we should now see the text. After the break, we access the cursor, and we are going to write our own things here. Changes were not applied, new code fails. Why? Rebuild. Oh, we still have to open this database? Yeah. I think .exit is exit. Yes. Now we should be able to rebuild, reinstall, and restart app. Okay, here it is. Good. We do 15 minutes break now, so we go on in 11 and 32, 33. So have a 15 minutes break now. Okay.
All right. Yeah.
Thank you, Professor.
Yeah. Thank you very
Thank you
much.
too. See you afterwards.
No problem.